All right, welcome to the notes from 6E on special right triangles. This is going to be really exciting. It's a little bit difficult um, just based on work we have to do with radicals, but there are some very distinctive patterns we're going to look at. And if you study these patterns, you should have no problem. So the first kind of special right triangle we're going to look at is a 45, 45, 90 triangle. That is an isosceles triangle that is right, and it has acute angles that are both 45 degrees. You can see it labeled right here. We know that in isosceles right triangles, both legs are congruent, and the length of the hypotenuse, no matter how long the legs are, the length of the hypotenuse is always square root of 2 times the length of one of the legs. We know that that relationship exists. We can prove it. And so we use that to determine lengths of sides that are missing. So the relationship can be written as a ratio where we have leg, hypotenuse, and that is x, and x times the square root of 2. And then I'm going to show you also how to put it in a chart to kind of organize our information. So if we take a look at this, for example, find the value of each variable. So right here, if we're looking for the value of h, okay, we're looking for the value of the hypotenuse of this triangle on the left. Over here on the right, this is the table I was telling you about, where you can kind of organize and set up your data. So if we were to use this table for the triangle on the left, we have, let's just take this and we'll use it twice. If we have, this side is 9, we know that this side is also 9 even though it's not labeled. The hypotenuse is just the leg times square root of 2. So literally that's all you have to do. The h here equals 9 times the square root of 2, and you're done. You have to remember that the hypotenuse is the longest side, and you have to remember that it's square root of 2 times that, but that's it. For this one, and again, we can set this up in the chart by this. We would put a 9 here, a 9 here, and then underneath the square root of 2, that would be h. And the way what we do here is then we can just cross multiply. We end up with these ratios are all true, so 1 over 9 equals the square root of 2 over h, and then when you cross multiply that, you get h equals 9 times the square root of 2. Alright? Same thing works over here for the one on the right. If you set your own table up, okay, and I'm just going to use the same table again, but you can draw your own. If I set this up, one of the legs is 2 times the square root of 2, and the hypotenuse is x. The other leg is obviously also 2 times the square root of 2 because it's an isosceles triangle. Let me get rid of this so we can set up a new equation. So again, these are ratios that are all equal to each other. 1 over 2 times the square root of 2 equals the square root of 2 over x. So that's what I'm going to write. 1 over 2 times the square root of 2 equals the square root of 2 times over x. Cross multiply here, and I get x equals 2 times the square root of 2 times the square root of 2 is the same as 2 times the square root of 4. The square root of 4 is 2, and 2 times 2 is 4. Now that may seem confusing to you. If it is, break out your handy dandy calculator, and you have 2 times the square root of 2, okay, times the square root of 2. And that should give us 4, which it does. Okay, so your calculator will help you with that if you need it. Let's take a look at the next one. So let's try your own. I'll work the problem with you as we go through. Some of you may want to draw a picture. Some of you may not need a picture. You know, it sort of depends on your personal preference. I like the picture, so I'm going to set up. Look at that beautiful triangle. Gosh. When I leave this job, the professional art community is going to really enjoy my work. So 45, 45, 90. The legs are 5 times the square root of 3. So 5 times the square root of 3. That's a 5. Yikes. And then we're looking for the length of the hypotenuse. So then I'm going to set up my table. Now, how you know, your table needs to be, I like to set it up like this, almost just like a tic-tac-toe board. And then I'm going to have, I have a leg, and the hypotenuse. The relationship between the legs is 1 to 1 and then square root of 2. Okay? And that's just like the page before. This just looks a little bit different. but it's the same idea. This is how I'm going to organize my data. The legs were both 5 times the square root of 3, 5 times the square root of 3, and the h is what we don't know. I again have my ratio set up now, so I just have to cross multiply. 1 times 8, and I'll write it over here as a ratio, as a proportion. Cross multiply, and I get h equals 5 times the square root of 3 times the square root of 2 is just 5 times the square root of 6. And that's your answer. That's all you have to do. It says leave your answer in simplest radical form. If it said round it to the nearest hundredth, then I would actually put this in my calculator and figure out what it was. But because I read the directions, knowing is half the battle. So simplest radical form is the answer. That's it. Let's try another one. 45, 45, 90. If you want, you could pause the video right here, try it on your own, and then check your answer once you've done that. So if you want to pause the video, go ahead and pause it now. Otherwise, I'm going to work the problem. Here's my triangle again. Yikes. Man, that's a good triangle. All right. And I'll mark it as an isosceles right. So it's 45, 45, 90. The hypotenuse is 10. Here, we don't know the leg. So it's a little bit different. Let me set up my tic-tac-toe board. So we have the leg, and the hypotenuse. That's 1, 1, square root of 2. And those are always the same. Okay, those are always going to be the ratios. The leg is what we don't know. So that's x, and that's 10. All right. Let me set up 1 over x equals the square root of 2 over 10. I'm going to cross multiply, and I get 10 equals x times the square root of 2. Now, earlier this unit, we worked on rationalizing the denominator. We're going to have to do that here because when we divide both sides by square root of 2, we get x equals 10 over the square root of 2. Okay, you can't have an answer with a square root with a radical in the bottom, so I'm going to multiply this by the square root of 2 over the square root of 2. That's a version of 1. This rationalizes the denominator for me. Okay, and now what I have is x equals 10 times the square root of 2 over, and square root of 2 times the square root of 2 is 2. One final step, and that is because 10 is divisible by 2, I'm going to simplify this one step further. 10 divided by 2 is 5, so x equals 5 times the square root of 2. That is a 5. And that's your answer. You can check to see if you've rationalized the denominator correctly in your calculator. If I put 10 divided by the square root of 2 in my calculator, I get this 7.07 whatever blah 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 number. If I want to check to see if I've done it right, I can do 5 times the square root of 2, and I should get the same exact number. If you get a different number, you've done it incorrectly. So your calculator may not simplify the radical for you, but it certainly will allow you to check your own work. Let's take a look at the next page. There's two kinds of special right triangles. So 45, 45, 90, which we just did, and then 30, 60, 90 triangles. 30, 60, 90 has a different setup for the ratios, okay, a different set of proportions. You have the short leg, which is across from the 30, okay, and that's why we learned that already this unit. You have the long leg, which is the short leg times the square root of 3. And you have the hypotenuse, which is just double the short leg. And this ratio exists every time, okay, every time. So what we're able to do is we're going to set up another kind of tic-tac-toe board looking thing. All right, so here's what it looks like. A little bit different because instead of having leg hypotenuse, we're going to have short side. And some people set it up 30, 60, 90. I like setting mine up like this, SHL. So you have the short side, which is 1, the hypotenuse, which is 2, and the long leg, which is the square root of 3. The reason I set it up like that is because 1, 2, 3 is just easier for me to remember. Then I have to plug in the values that I'm given underneath their corresponding side. So the short side was across from the 30, so that's x. The hypotenuse is across from the 90, so that's 8. And the long side is across from the 60, so that's y. Just like the one before, these are 3 proportions now that are all equal to each other. So I can write this out as 1 over x equals 2 over 8 equals the square root of 3 over y. And then I'm just going to solve for x and y one at a time. Okay, 1 over x equals 2 over 8. Well, that's easy. X equals 4. Then over here, I'm going to use, you can do 2 over 8, but I'm actually going to use 1 over 4. Now that I know this is 4, I can say 1 over 4 equals the square root of 3 over y. I do that so that I don't have to simplify later. I did my simplifying up front. Y times 1 is y. And 4 times the square root of 3 is just 4 times the square root of 3. And that's it. Okay? Easy peasy. How many of you in your head just said lemon squeezy? You should be embarrassed. Mr. Douglas is raising his hand. So here's the chart for that. Okay, like I said earlier, some people like to use the chart. You have this in your notes. It's set up like that for you. So let's do another one. If you want to pause the video and try it on your own, that's fine. If you want to continue working the problem with me, then that's also fine. I'm going to use the tools here to draw a little bit better of a calculator than the ones that I've been drawing. So here's the 30, 60, 90. The hypotenuse is 12. Okay, we'll say that's the 30 and this is the 60, and we'll just call them x and y. Okay, and it says leave your answer in simplest radical form. So now I'm going to plug these into the chart that I've created. This chart is a little bit different than the one I use, so I'll do it on this one. This one is 30, 60, 90, and then 1 square root of 3, 2. The way that I did it on the page before was SHL, 1, 2 square root of 3. You just have to pick which way you like more. Okay, it doesn't matter. You'll get the same answer either way. So the y goes there. The 60 across from the 60 was square root of 3. And that's x. And then the hypotenuse here was 12. Same idea. I have 3 ratios that are all congruent. So 1 over y equals the square root of 3 over x equals 2 over 12. Well, again, finding y should be easy. 1 over y equals 2 over 12. So I know right away that y is 6. Okay, y is 6. And then 1 over 6 equals the square root of 3 over x. X times 1 is x. And 6 times the square root of 3 is 6 times the square root of 3. And there's the length of both legs. Look at that. That is pretty. Man, that's good looking. Alright, let's take a look at the next one. So just another problem. Go ahead and set up your chart however you want. You know, it doesn't matter which way you choose. It just matters that you pick one way and you do that way every time. That way you get good at it. Mr. Douglas disagrees. He wants you to be versatile. I just want you to be habitual. Okay, so 1, 2, and square root of 3. I like doing it this way, and from my experience, students seem to remember 1, 2, square root of 3 easier. And yeah, I don't know what the rest of that sentence was. Okay, the short side, that is across from the 30, so that's D. The hypotenuse is F, and the long side is 5. All right, so here we go. 1 over D equals 2 over F equals square root of 3 over 5. So you pick one variable and you solve for that, and then you use that to find the other one. So let's do 1 over D equals the square root of 3 over 5. I get 5 equals D times the square root of 3. We're going to have to rationalize here. I divide both sides by square root of 3. And I get D equals 5 over the square root of 3. Okay. Once I'm there, I'm going to multiply the top and bottom by the denominator. Okay. This gives me D equals 5 times the square root of 3 over 3. Is that an ugly answer? Yes. Is it the answer? Yes. So that's what D equals. To find F, we have to go back and look up here, and you'll see that F is just twice what D is. So 2 times this. Well, 2 times this, F is just 10 times the square root of 3 over 3. Earlier, you'll remember that we simplified a fraction to look like this. We could do that because 10 was divisible by 2 earlier. 10 is not divisible evenly by 3, so these are your answers. Okay? Are they pretty? Like I said, no. Are they the answer? Yeah, those are the 2 answers. Okay, so D right here and F right there. Let's take a look at the last one. The shorter leg of a hypotenuse, of a 30, 60, 90 triangle has a length of square root of 6. So let's set up our grid. SHL 1, 2, square root of 3. The shorter leg, so then I'm going to put, excuse me, the shorter leg is square root of 6. We don't know the hypotenuse or the long side. All right, so let's take a look. The hypotenuse is pretty easy. 1 over square root of 6 equals 2 over x. X times 1 is x. And then this is just 2 times the square root of 6. That's it. You're done. You're done with x. Let's find y. So 1 over the square root of 6 equals the square root of 3 over y. So y equals the square root of 18. But the directions say simplest radical form, so I need to check and see if I can simplify that radical. Is there a perfect square that goes evenly into 18? And the answer is yes, 9 does. So y equals the square root of 9 times 2. Y equals the square root of 9 times the square root of 2. Y equals 3 times the square root of 2. And you're done. Those are the notes. Make sure you get those done. Come in ready next class for the quiz on the first 2 days. Until next time, goodbye.